Next up, third presenter we have from the Department of Psychology and Neuroscience. Please welcome to the stage, Elise Aronitz.
If you think about it, the visual system and Play-Doh are a lot alike. I know it sounds strange, but hear me out. When you first open a tub of Play-Doh, it is extremely pliable and you can squish it and mold it using outside force. Like Play-Doh, just after eye-opening, connections between cells within the visual system can be molded by an external stimuli, in this case, by vision. However, similar to Play-Doh that has been left out for a long time, an older visual system is less plastic and therefore harder to mold. Plasticity within the visual system follows the curve shown on the slide. During early development, there's a period called the critical period, during which the visual system is extremely plastic, and the connections formed and refined as a result of vision lay the groundwork for adulthood. Because this period is temporary, but so important, any disruptions to vision during this time can prevent the visual system from developing properly and lead to the developmental disorder called lazy eye. On a global scale, lazy eye is estimated to affect 2 to 5% of the world's population. To put that into context, 5% of the global population is equal to about 370 million people. That is 10 times the population of Canada. The current gold standard treatment for lazy eye is eye patching. However, it has very poor patient compliance, and by about the age of 7, patching results in little to no recovery. So, finding a more effective treatment for this disorder is extremely important. Interestingly, using an animal model of lazy eye, the Duffy lab has shown that 10 days of complete darkness increases plasticity within the visual system and allows for better recovery from lazy eye. Although more effective, in a clinical setting, darkness is not very sensible because it's generally frowned upon to put a kid in the dark for extended periods of time. So this is where my research comes in. My research aims to gain a molecular understanding of how darkness alters the visual system and to shine some light on the proteins responsible for the increase in plasticity. We developed a new method to examine the ratio between 2 specific proteins because it is thought that the ratio between these 2 proteins alters how the visual system responds to stimulation and therefore alters plasticity. Because the structures of interest within the visual system are organized into layers, and the method we developed allowed us to preserve the original place of the proteins within the tissue, we were able to examine the ratio change in a layer-specific manner, which has never been done before. Using this new method, we were able to show that darkness does alter the ratio between these 2 proteins, and interestingly, the change is not layer or structure specific. Although we only examined 2 proteins, and there are many more out there to go to get a true understanding of the mechanisms of plasticity, my research shines some light on the molecular mechanisms of a more effective but less sensible treatment for lazy eye. And it gave us some fundamental information about the visual system, and it adds one more piece of the puzzle that will eventually help us create a new and more effective treatment for this disorder that affects so many people. Thank you.